Hey everybody, welcome to today's Kubernetes Masterclass. Really happy to have you all joining us today for this really cool session. We're going to be talking cloud native telco evolution with CloudOps. It's going to be great. We do have a lot of people joining the line, and as more people join, I just want you all to know that this session is being recorded, so you will receive the recording as well as the slides following the session. We have about an hour to 90 minutes scheduled, so we should have plenty of time to get to the material and to your questions. But if you need to drop off for whatever reason, you will get a recording in the follow-up afterward. So as a way of introduction, my name is Matthew Shearer. I'm a marketing manager here at Rancher. I help host these sessions and our intro to Kubernetes and Rancher training sessions on Thursdays. Please reach out to me through email, matthew@rancher.com, or Slack, the Rancher Slack, slack.rancher.io, and my Slack name is just Matthew. If you need any help getting the recording of the session or another one or anything else, we're really happy to connect with you all and help you get what you need. We have Will and Alex on the line, and I'll let them introduce themselves shortly from CloudOps. Are you guys still there?
Yep, we're here.
All right, awesome. Okay, welcome. Should be great. So just a couple housekeeping items before we dive in. So we did try to keep this, to about an hour, 45 minutes. We'll see, how long we go. We try to be really available to everybody's questions and just answer as many as we possibly can. The questions tab is where the chat tab is where you can ask your questions. If you want it to be private, just mark it as such. Otherwise, we will, answer it for everyone's benefit. And if we're unable to answer a question, we'll send you to another resource or the Rancher Slack or forums, and there's a huge community and plenty of ways to get support. This session, as I mentioned, is being recorded. All of our sessions in this series are totally free and available online. If you go to youtube.com and youtube.com/c/rancher, then you'll be able to see all of these classes, the recordings for all of these classes, and get what you need. For some reason, it just took me out of presenter mode. That is annoying. Let me just get back there. So you'll receive the slides and the recording after the session. We put our online meetups up, our intro trainings as well. So there's just a ton of good video goodness on YouTube for you to enjoy. If you want to connect more with our community, I think many people who are already on here are pretty plugged in to the Rancher community, but it's totally free to join, get help, and participate. Slack.rancher.io. We post announcements about these sessions on our Pound Masterclass channel, so you can join that as well to hear upcoming classes, and sometimes a presenter will have a manifest that they put on Git for their demo or something like that. If you want to be able to grab those files, we usually post them there as well. So please join that. And we have a lot of cool upcoming sessions as well in June on Istio, on securing production, a lot of cool stuff. So please, check those out and join. This is just free learning, and it's a complex field, so there is just a ton to learn about on various topics. So with all that out of the way, I am going to pass this presentation over to Will so you can get started with what you all really came here for. So Will, I'm going to make you the presenter.
All right, there we go.
And I see your screen. Good to go.
Perfect. All right, well, welcome everyone. So this masterclass is going to be around cloud native telco, and basically the changing face for the telco industry on how they consume and deliver technology and their services. So about us, my name is Will Stevens. I'm the CTO at CloudOps, and with me is Alex.
Yeah, my name is Alexander, or Alex if you prefer, and I'm a container solutions architect
working for CloudOps. So CloudOps is a services company. We specialize in helping organizations own their destiny in the cloud. We really focus on enabling organizations to consume open source technologies as a means to own their destiny, and we definitely leverage automation substantially in the process. So without further ado, let's jump into it. So start off with, like, what is cloud native telco? And you're probably going to get some different definitions from different people. So I'm just going to give you a kind of a quick idea of what I think it is and how I think it fits into the market. And we can, if you have additional questions or have other things, then we'll be taking questions throughout. What we'll probably do is we'll probably stop and take questions right before the demos, but feel free to ask your questions. And we're going to start off relatively high level and descriptive, and we're going to get deeper and deeper into the technical weeds as we go. So if some of this stuff feels a little too high level for you, don't worry, the technical goodness is coming. And so we have 3 demos at the end of this session. So we'll get into the technical weeds there. So cloud native telco. Basically, telcos are adopting containers and microservices to deliver their network services. And this is really being driven by a need to modernize their technology stacks. They have a growing requirement for being able to leverage API-enabled, software-enabled technology stacks, such that they are in better control about the services that they deliver and how they deliver them. With services such as 5G coming very soon on the horizon, the number of devices that are on a telco network is going to balloon very quickly. And in the current state, the level of automation, the level of sophistication around their service delivery and such, it has to improve in order to be able to handle the onboarding of that number of devices and handle it in a realistic way. So a lot of that is transitioning a lot of their services from traditional legacy services now to containers and microservices. So this is very much a journey, and one of the things that that telcos are very much struggling with to some extent is that they have a lot of legacy in their technology stacks. They have vendors embedded at pretty much every layer, which makes it very challenging to be able to innovate and actually change with technology as the technology evolves. And a lot of their technology, since it is relatively old, lacks the ability to automate or doesn't have the APIs to be able to actually get to DevOps and so on. Now, what they're looking to solve for is they're trying to get to the point where they have a lot more control over their technology stacks and their data centers. So being able to have agility both in the technology and in their practices of how they maintain that technology, how they upgrade it, how they deliver new services to customers, and so on. And instead of just paying a vendor to deliver some services, they want to be able to own that process and make sure that they actually own the outcomes of what they're offering as services to their customers. And really, in the end, the hyperscale clouds have really pushed the envelope on what consumers expect from their service providers. And so pretty much everybody expects that they're going to be able to do on-demand self-service of modern technologies. And that is something that the telcos have not necessarily solved for in the past. They They are very good at managed services. They're very good at being able to make it work, but the whole on-demand self-service of technologies and services is, it's not something that the telcos have a lot of history in solving for elegantly. So one of the things that I think is really driving this is Kubernetes. In my opinion, Kubernetes is one of the most influential technologies that I've seen in the last decade or more. I've seen more organizations who have failed to adopt previous iterations of like cloud, for example. I've seen markets I've seen companies in many different markets, all adopting Kubernetes in a very real way. But the challenge with that is that a lot of the organizations that are adopting Kubernetes are adopting with operations teams who are used to operating traditional IT. Think of Cisco boxes, think of VMware, think of like basically operating traditional infrastructure in their data centers, and that's just what they know. So there's a pretty substantial gap for a lot of these organizations adopting Kubernetes and being able to level up their team to be able to actually operate Kubernetes such that they can make it available for developers, make it available to their teams to be able to deliver services on top of it. And this is one of the things that I think Rancher has noticed very early on. And RKE is a really nice balance between the putting in smart defaults and making the it's a nice balance between operational enablement and some convenience there, but also staying relatively true to the underlying Kubernetes platform. I think that's really important because as Kubernetes evolves, it's the more layers you put on top of it, the harder that is to maintain. And I think that RKE has done a really nice balance about making it operationally viable while also staying quite true to the Kubernetes platform. I'll throw a little plug in here for CloudOps just before I move on. Basically, one of the things that we offer is Kubernetes training. We're one of the first, and I think we're still the only certified Kubernetes training partner in Canada. And one of our workshops, the Docker and Kubernetes training, is very, very popular and has helped a lot of organizations adopt Kubernetes. And a plug. All right, so if we're going to talk about Kubernetes and telcos, it would be amiss for us to not mention edge computing and K3S. So basically, the hyperscale clouds have kind of monopolized the consumer computing market. Most organizations, if they just need a VM, they'll go to a hyperscale cloud now, and the telcos are really getting kind of pushed out of that game in a lot of ways. But the telcos own the last mile, and they have a large amount of infrastructure investment at the edge. And I think K3S is a really interesting distribution of Kubernetes for being able to enable the DevOps practices, the automation, the technology investment around Kubernetes, but on a set of hardware that is a lot more resource constrained. So I think that K3S is going to be quite interesting for telcos as they enter the edge technology stack. All right, so now we're starting to get into the weeds. So one of the biggest challenges in adopting Kubernetes is that it actually takes a lot more a innovation, or let's see, it's a bigger transition. When Cloud 1.0 is it's what I call it anyways, happened, where we have AWS and then Google and Azure, organizations were able to adopt cloud with basically a lift and shift mentality. They didn't have to rewrite their code. They didn't have to re-architecture. They basically could just be like, oh, I'll run this in the cloud. And for the most part, it worked. But now with containers, and especially microservices, it really forces an architectural change in how the actual services are delivered to market. And so it's a separation of technologies. It is more of a this service only delivers this and depends on these other services. So it's really an ecosystem change. And that really requires DevOps practices and automation to be able to do that in such a way that is going to be effective over the long term. So one of the things that I've seen is that organizations, they have to be opportunistic about what technology, what services they're going to migrate to Kubernetes or containers or microservices. And so they start with the easy ones and they get them moved over to Kubernetes, but then that means that they have segmentation on how their services are delivered. Some are delivered through Kubernetes, some are delivered on legacy telco infrastructure. And so you really at that point need to be able to have interconnectivity between those different services, the old and the new. So I threw this one in here. I'm going to be doing a demo on this later, but being able to BGP peer your Kubernetes cluster with your telco, like your legacy networking, is something that I think offers a lot of value to telcos as they make this transition, because it enables them to move the services that make sense to move and that are easy to move, but still be able to maintain the same level of connectivity between their services without necessarily having to move everything. So for cloud native telco, one of the biggest things that telcos in terms of a workload need to solve for is networking. And the networking problems in telcos are, they're a lot bigger than most organizations. If you look at just like a software company or something like that, their network requirements are okay. They're all right, but they're nothing crazy. Telcos, they carry a lot of data, and so the ability to do network acceleration in containers is pretty much table stakes for telcos. So there are a whole bunch of different ways to do network acceleration through containers. This is not an exhaustive list in any sense, but I wanted to bring up a few just to kind of get people thinking in this way. So DPDK, basically, it's a set of libraries that moves the packet processing into user space. So in this case, into containers. Anything you want to add to that? Sorry, I've been dominating the conversation. Alex is going to be a lot more involved as we get going.
Not a problem. Yeah, DPDK is a set of libraries that allows us to develop applications that actually process packets on top of the user space and not anymore using the kernel space in Linux. So, which means that you have full control and you can actually scrape out the inefficiencies that we find inside of Linux kernel. So this is one of the tools that most of telcos nowadays have been using normally inside of VMs, a big chunk workloads running in VMs. We're gonna talk about that in a little bit. And yeah, if I can keep going on, we still can see like SRIOV. which is a very special piece of technology that virtualizes, let's say, the queues inside of an interface, a network interface card, allowing to have multiple networking virtual functions in hardware, and thus accelerating and maybe making possible to have multiple workloads on the same virtual interface, virtual network function on top of the network interface card. The same way we can have some special interfaces, network interface cards like the SmartNICs. They are specialized in actually receiving offloaded, programmed networking process on top of it. And eBPF is one of the technologies, for those who don't know what eBPF is. eBPF is Berkeley packet filtering. And in this case, eBPF is a set of multiple programs that you can actually use inside of Linux kernel, but it's not the traditional Linux kernel. So it has a bunch of very smart, optimized functions. And one of the programs that you can use is XDP. And XDP is the one that can be offloaded to hardware. So when you do that, you actually you bring out of the kernel everything, you bring out of the CPU, and you let the network interface card process everything. So those three tools, DPDK, SRIOV, and eBPF with the XDP, they are all leveraging very special network interface cards and accelerating a lot the packet processing. So most of the telcos nowadays, they use a lot of those technologies. And to make a note, there is the VPP project, which is vector packet processing. It was released by Cisco, and open source. I think it was from 2012, if I am correct.
Sounds about right.
Yeah, and this is a way of programming virtual network functions in user space, and all of those, they could be used together, combined, depending on the scenario that we are seeing. So all of those tools are actually are used to face the challenges when it comes to having heavy workloads with lots of bandwidth utilization and heavy bursts of traffic.
Awesome. All right, so now that we've kind of gotten a little bit into some of the networking stack, one of the little known facts about Kubernetes is that the network I/O is actually not accounted for in the scheduling of Kubernetes when it comes to the resources that are assigned to pods, for example. So if you have a pod that has 2 CPU and 4 gigs of memory, for example, that is the CPU allocation for that user space. But the network I/O for that pod actually happens in kernel space. So in a lot of cases, the network I/O is kind of the dark matter. It's not really accounted for appropriately, and so that can cause some capacity management issues if you are dealing with high I/O workloads, but and you're trying to optimize your placement and such, because it is not necessarily accounted for as well as you might think it is. So there's a few ways to handle this. One being DPDK, for example, enables you to move the packet processing into user space, which means that the packet processing would be using the resources that are assigned to that pod in Kubernetes. So in a lot of ways, that will reduce the network I/O on the host itself. the handling of the network I/O. Another would be to do offload to, say, a SmartNIC, for example. So in this case, I have eBPF and XDP as an example, using XDP offload to basically offload that processing to a SmartNIC. Anything you want to add to this one?
Yep, that's it.
So beyond running containers and doing network acceleration in containers, one of the other areas that telcos are likely going to be forced to adopt is being able to schedule VMs in Kubernetes as well. There's a bunch of reasons why people would want to do this. Basically, if a workload is hard to containerize, then being able to run it as a VM, but orchestrated in the same contextual environment, having access to all the same exact networking and so on, can definitely have its advantages in certain scenarios. There are quite a few different technologies that are available to solve this. This is not an exhaustive list. There's things like HyperSH and so on that are not on this list, but just to give a few different examples here, Kubevirt, Virtlet, and RancherVM, they all basically use QEMU and KVM acceleration. Kata containers, slightly different. They use QEMU Lite. And then Google's gvisor, for example, is basically a custom kernel that runs in user space. Anything you want to touch on this before we?
Yeah, I think there are three key benefits that we could stress or highlight on those. One is speed to adoption. Sometimes companies are looking for deploying containers with VNFs and they have a lot of legacy or traditional software running into VMs, and they want to share the same platform. So this is one key benefit. And this sharing of the platform, which will allow them to have actually monolithic applications, not only VMs they are trying to containerize in the future, but more than that, some of those VMs need to be re-architectured. So the only way to run on the same platform will be bringing a VM, because you're not going to be able to containerize, for example, a VM that is actually running like 20 or 30 processes inside, components that are extremely highly coupled, and you don't have like a microservice architecture approach to them. And the other thing that I think is a great benefit is that once you are inside of this platform, and once your team begins to get used to Kubernetes and everything else, then you are actually opening the door to evolve all your platform and all your services to a microservice architecture. So it kind of pushes you to the next level, to the next phase. It helps doing that.
Yeah, and that's also what I was going to mention as well, is that as organizations adopt Kubernetes, it changes the way that they are developing code usually. So they end up with more pipelines, end-to-end integrations, and basically DevOps tooling to support the application lifecycle for their application. The lifecycle for their applications. So being able to manage code that is still on traditional VMs in the same process and with the same tooling and so on, it simplifies the life of the people who are operating and maintaining these services over time. The other thing where VMs come into play is if you're getting an appliance, for example, from a vendor, and it's not containerized and needs to be run in a VM, then this is a type of scenario where you would likely be able to introduce it into the same ecosystem without necessarily interrupting basically without having to provision specific infrastructure for that that appliance. All right, so now we're going to dive into essentially one specific implementation, and we're going to choose Kubevirt for this one.
Okay, so basically Kubevirt is one of the tools that allows you to run a VM inside of Kubernetes, and it provides obviously the same strategy as you have for your pods, for example. So can you please go one further?
Yeah, sorry.
Thanks. Yeah, so just to give you an overview, I'm going to show that on the demo, but just to give you an overview. So here we have a few resources, a few new resources that actually will be used by Kubevirt to actually deploy your VM inside of Kubernetes. It's not only deploying inside Kubernetes, but more than that, the VM is actually being run inside of a container. And sometimes it seems kind of awkward when we say like that, because a container seems to be something very small and a VM seems to be something very big. But in the end of the day, a container is actually an isolation process that is leveraging namespaces and C groups. And we can actually run a VM inside of a container if you have the platform running inside of the container. So here we see a picture where the API is actually commanding a few special pods that is handling all the libvirt, which is the API for KVM, and also QEMU, which is the emulator that will run the image for you. And on this image, you can actually see the virt handler as being one of the pods delivered as a daemon set. And for each VM, you will have a special pod that is called the virt launcher. And that virt launcher will be talking to libvirt, actually is spinning up a VM for Kubevirt inside of Kubernetes. And all of those resources, they are actually modeled and developed using CRDs, which are custom resource definitions under Kubernetes that allows you to create new objects under the Kubernetes API. And with that, you have the possibility of just running kubectl commands, watch your VMs and see the state of your VMs using the same way you use for your pods. Go ahead. And here we have just an example. We are going to pass through in the demo just to show you guys that actually we have defined a VM, a very simple one with just a YAML file, just the same way you do with your pods. In this case, the object is a virtual machine. It's not a pod. It's a kind virtual machine. So here you have many entries. Most of them are not here because if you go to the Kubevirt project or GitHub, you see that there is tons of possible tweaks and customizations that you can do inside of this YAML file according to your requirements.
So basically, this doesn't handle everything around running VMs in Kubernetes, obviously, but we wanted to give a bit of a taste because I think specifically for telco workloads, it's very relevant and something that needs to be solved for as they adopt Kubernetes and microservices, especially due to the amount of transition in the way that they work. There's going to be outliers that have to be handled in virtual machines as they modernize their delivery and technology stacks. So yeah, here we have just a list of a few things that VM orchestration can help solve. Reduces the adoption of Kubernetes, for example, making sure that the containers and VMs are on the same network, and really making sure that the alignment of the DevOps practices that are being leveraged by the team, especially the team that's using Kubernetes, is able to handle workloads that don't fit into the standard container requirements. So basically, now we're going to be switching a little bit more into some of the technical weeds on the networking side again. Basically, one of the challenges, especially that that NFV workloads have in trying to run on Kubernetes, is that by default, Kubernetes only spins with a single NIC. And a lot of the different NFV implementations really expect you to have more than one network interface. Things like wanting to have one NIC dedicated to management, another NIC dedicated to the data plane, for example, and so on. So this is a bit of a challenge that as you get to trying to adopt NFV or modify or onboard NFV workloads into Kubernetes, this becomes one of the first stumbling blocks you run into of, okay, how do I handle this network segmentation in this pod? How do I actually handle the fact that I need to be connected to more than one network to be able to not re-architect this NFV implementation? Do you want to add to that?
Yeah, sure. I think the most important benefit is actually having multiple interfaces. Each and every VNF that we deploy, it may be a firewall or a router or a packet filter or inspection kind of device, virtualized device, or a border session controller, any special gateway with special functions that you want to develop, you will need multiple interfaces. But Multus goes a little bit further, because Multus will allow you to have multiple protocols also. Because on those multiple interfaces, you may be able to run different protocols depending on the CNIs you are actually giving Multus to control. And one of the things that is interesting is that Multus can also work with Kubevirt, for example, and with other platforms to have multiple interface VMs also under Kubernetes.
Oops. Oh, sorry, making sure that didn't get
okay.
Perfect.
So the motivation behind Multus is actually all of that. So if you are actually into developing VNF, you know more than anyone that you need to have multiple interfaces, and this is probably the major challenge in the container world that we are facing nowadays. We have Multus. I saw some conversations inside of the container orchestration interface, trying to put that natively into Kubernetes, and I see that coming in the future. But I think Multus is the one that is actually being used for the telcos nowadays.
Yeah, the telcos are kind of forced to be early adopters in this space because of the workloads that they run. So we've seen Multus being adopted primarily because it seems to be the front runner in terms of being able to support these types of functionality. And so since the telcos are being forced to adopt ahead of the market on this, this is the implementation that we've seen them adopting. I agree that I expect that Kubernetes likely will handle this natively at some point, but until then, we have Multus.
Yeah. That's it. Basically, how does Multus work? Multus is actually orchestrating CNI plugins underneath its ecosystem. So Multus is it's called also a meta CNI plugin. It actually has, let's say, a list of CNIs that can be used with any pod. And with that list well configured, you can actually deploy pods, and putting a special annotation on the pod. We are going to see that in the demo. A special annotation, you will be able to actually use that particular CNI. The only caveat here is that Multus needs a primary CNI plugin, and that primary one is the one that Kubernetes will be actually aware of its existence. The other ones, the secondary networks, the secondary CNIs that you are going to use, the secondary ones, Kubernetes will not be aware of them. So all the tuning, the specifications, the maintenance is yet outside of the Kubernetes world. You can see them, you can configure them through Multus, you can tweak them, but it will not be completely integrated with Kubernetes in what concerns like registering information into the etcd data store, for example, and things like that.
Yeah, one of the side effects to that is that Kubernetes will not be able to operate them and be able to apply network policies, for example, on the additional network interfaces, which is important to note.
Yeah, and then in here we have a kind of a representation of what we see after deploying a pod with multiple interfaces. You see that you have what is called in the figure at right, cluster network master plugin. This one will be the primary network. The other ones, they will be part of a set of network attachments. We call it like network attachments, but it is actually a CRD. It is a custom resource definition under the Kubernetes API that we create to define which kind of configuration we want for each one. And the process, when we see the configuration process, you see that the CRDs, they will be created. After the CRDs are there, we can actually create a pod referencing those CRDs. And as those CRDs are network attachment definitions, when the pod is in the process of creation, the master will assign the pod, and finally Multus will actually activate the proper CNI plugins and mount, if we can say like that, and build those interfaces inside of the pod and deliver the pod with those networks, those additional network interfaces.
All right, so now we get to demo time, the fun part. I'm going to pause here and see if I can take some questions, if I can find them.
Yeah, Will, I can just read the one we have out loud. Fantastic information so far, guys. This is awesome stuff. So we do have a question. This was asked, I believe it was back when you were talking about I/O usage. And so he says, do you recommend this as a way to measure benchmarking on Kubernetes? How should an application know its real capacity and compare different revisions?
Yeah, that's a really good question. And really, when it comes down to it, I think that from a user's perspective, I don't really think you have to worry about it. You really only care about it if you are operating the Kubernetes deployment. If you're operating the Kubernetes deployment, I'd recommend that you have monitoring on your actual Kubernetes infrastructure. You're going to be able to have a delta between the amount of allocated CPU that is allocated via Kubernetes. So for like CPU that is allocated to pods, for example, and then you're going to have your real number of how many CPU cycles is this host actually processing, for example. Keeping track of that delta of what's the real CPU usage on these hosts versus how many CPU cycles are allocated to this host through pods is important to keep track of, and that's where you're really going to be managing your capacity from is the actual usage on the hosts. In terms of tooling through Kubernetes and such, I'm not sure. I would recommend basically monitoring on the hosts themselves to capture how close you are to your capacity on that front.
Cool. All right. Awesome. Thanks. That's the only question so far. So just a reminder to everyone, this is a great opportunity to get your questions answered, and because we have time. So, but keep going, guys.
what I'm going to do is I'm going to switch over to Alex's screen, and Alex is going to give us a demo. And let's just.
I should. Okay. So now I think you can see my screen now, right?
I can see your screen.
So here we put up a very simple demo based on the Kubevirt project, just to show you guys what it is all about. So basically, if you want to install Kubevirt, I just copy and pasted here a few commands just to show that we first deploy an operator that will be kind of setting up the environment for Kubevirt to work. Then we deploy Kubevirt itself in a simple YAML, and then you have a bunch of objects inside of Kubernetes that will be able to handle AVM per se, and then we have the VM YAML that could be applied there to actually run the VM. So let's take a look on how it works. So once I deploy the operator, I'll be able to see a special pod on a new namespace called Kubevirt. So here we'll be able to see this operator just waiting for Kubevirt. Once we deploy this operator and this operator is already running, then you can deploy Kubevirt, and then all of those pods will appear also here on the Kubevirt ecosystem. And those pods are actually doing what you saw on that picture, on that diagram, showing the flow between Kubernetes API and Kubevirt pods. So once you deploy your VM, you're actually capable of doing kubectl get virtual machine instance, for example, and you can actually see your VM running over there, right? So there is a special tool which is called. Actually, before that, I want to show you guys a little bit this environment, because we already have some pods running multiple interfaces with Multus. But the most important information here, let me get a little bit more of information for you.
Minus O.
Yeah, minus OY. sorry about that. So then we can see that we have this special pod, which is the Virt launcher here, with which is actually serving our VM. And we have two pods. All of them are in the same network. So I have a special tool here, which is virtctl. Virtctl is a tool that will allow you to connect to this VM once you are actually able to connect to Kubernetes. So it's using
Virt or Virt?
It's so, yeah, good. you are fast, man. It's virtctl console. And then I can retrieve the name of my VM here. And boom, I'm inside my VM. It's a very simple example VM. But the good thing is, inside of this VM, if I do IP address, I can see that it's actually configured to work on the same pod network that was deployed in the very beginning when I deployed the cluster. So as you saw before, I had two other pods running here, and those pods, they have the end IP here is 10 and 11. So from my VM, I'm actually able to ping them, I hope, if everything is working well.
We haven't tempted the demo gods too much.
Yeah. So I can ping my pod. So I'm actually making a VM talking to the pod. So this is pretty cool. So if you have a solution and you need to mix up services, you have a VM, you need to put that inside of Kubernetes really fast, a monolithic application would work just fine. And just out of curiosity here, if we go and do kubectl get CRDs, for example, sorry, I am inside of the VM yet. Let me get out, and then now we can do that. So kubectl get CRDs. you see that we have a bunch of CRDs. One of them is actually, one of them belongs to Multus, which is this one, and all the others are actually CRDs created by Kubevirt in order to allow you to run your VMs. So another curiosity here, which I think it's interesting to show, is if I go to my node itself, where the VMs, actually the pods are actually running, and I quickly do a Docker PS instead of doing a kubectl command, and I look for Kubevirt, I can see a bunch of pods running. But the two first ones on the top here, the Virt launcher, and this one that seems to have a very, very interesting name and kind of similar to a VM name. If we go inside of those guys and do a Docker exec -it, and we grab, for example, this ID here, and we run a simple bash shell here, I'm capable of doing something really interesting. I can do virsh list --all, and I can list my VM from one container. So one container is actually running libvirt and all the KVM API orchestration system. And if I get out of this container and I grab the other container instead, let me try this. And we go and grab this guy here and do the same thing. I'm pretty sure we won't have here the virsh command, but we have something special, which is QEMU emg, let's say --, version, for example, just to show you guys that QEMU is actually running inside this container. So this is how Kubevirt is capable of running all of those things. So coming back to our demos here, this is pretty much the way things happen. So let me show you now the Multus one, just to be concise here. So, okay, so now we're good. So Multus, actually, I deployed Multus first because Multus needs to be the first one with your CNI plugin, the basic CNI plugin that will be running as the master, the primary plugin on Kubernetes. In this case, I'm deploying a very basic scenario here with a Multus daemon set and using a Flannel daemon set also, which is our CNI plugin responsible for those IP addresses that we just saw. When you deploy those two guys, we'll see that we have that. Let me show you here on the master. kubectl get pods -n kube-system. When you deploy that, you will have the basic Flannel pods that will be spread across your cluster, and also your Multus containers that will be orchestrating all the network together with the primary CNI to run the pods with multiple interfaces. So, and once you deploy those guys, you will be able to have your pods, kubectl get pods with multiple interfaces here. Let me show you guys real quick. So I'll just log into one of them. Like, let me first do kubectl get pods -oy just to show again that we have our primary interface having two IP addresses using Flannel. And then once I go inside of them, kubectl exactly -it, and we go sample pod then bash. So I'm inside of sample pod, and I can actually list my interfaces here. So here I have the basic Flannel one, and here I have another interface that is actually running a different protocol. So how does it happens? Coming back to our demo guide here, I can show you guys that I created this network attachment definition using one of the most simple CNIs that is actually available inside any Linux box, which is the macvlan.conf, which is actually an interface that is capable of, a virtual interface that is capable of having multiple sub-interfaces. And then you can configure those sub-interfaces the way you need using the basic CNI strategy with this JSON information. And if we come back to our cluster, we can actually see this information. First, when you do kubectl get crd, we see the network attachment definitions here as being one new object, and I can do then kubectl get network. Let me see if I can. It's not completing here, so somehow it's not getting the network attachment definition that we just try again.
Do you have to do CRD?
Yep, I don't think so. I can describe actually, I think. I can describe a CRD, which will be better. Let me see if I can describe the CRD here. Describe CRD and the network attachment. I should be able to get the network attachment definition. We can take a look. So yeah, here is just the CRD itself. But let me take a look here because I think I have it here somehow. It should work just fine. Let me see if I can actually do this. Yeah, we can. So here we can see that we have a special network attachment definition, and we can also describe this special network attachment definition. Oops. Good. And here we see the JSON file that we just put in. So the process actually is basically after you install Multus and Flannel, you create the basic CRD called network attachment definition. And once you create it, you can create many pods based on this particular network attachment definition. So how does the pod itself looks like? It just needs to have this particular annotation, and then it will have a secondary interface. So, and that's what we can see here on our pod. So real quick, what I'm going to do now, I'm going to just get the pod again, and I'm going to the second pod. We saw that, so kubectl exec minus IT, we grab the second pod, and then we just go inside. We check the IP address, and you see that it is running on 192.168.1.201, and then we're just going to ping the first pod just to show that these two guys are actually talking on, let's say, a backend network. Then routing, filtering, everything else must be developed with this kind of strategy in mind, having multiple interfaces. So it's a very, very basic, simple demo just to show you guys that you can run a VM and you can run also pods with multiple interfaces and create multiple networks using Multus. So I think I'm going to switch back to Will.
Perfect.
I just don't know exactly how to do that.
I will.
Okay.
Don't worry.
Thank you.
All right. So we're getting close to time, so I will get through this quite quickly. So this was the demo that you just saw, that Alex just did. I'm going to do another quick demo, basically to illustrate being able to peer together two different deployments. This is mainly to illustrate the idea of BGP peering together a Kubernetes cluster with a traditional network. But for simplicity, what I did is I essentially spun up two different Kubernetes clusters in different regions, did site-to-site VPN between them to be able to create a basically a layer 3 connectivity between the two underlay networks. And then I have Tungsten Fabric set up as the CNI for both of the Kubernetes clusters. And so I essentially set up a BGP peering between the two different Tungsten Fabric CNIs in the two regions. And I will show that I can have service-to-service communication between the two regions through this. So I will jump right in. Essentially, what I have here is, so here, I'll just log into one of my masters on one side. And what I'll do, actually here, I'll just do a cat bash profile grep kubectl. Because I have shortened my thing, I just use K for kubectl and KS for kubectl with the kube system namespace. I'm just going to throw that out there right now so that people are not super confused as I type things in the chat or in the terminal. So if I do KS get pods, whoops, pods. These are all the pods that are running on this in this environment. All of these here are specific to Tungsten Fabric, which is historically called Open Contrail, and is being currently transitioning from Open Contrail to Tungsten Fabric under the Linux Foundation networking. So it's referenced here as Contrail, but it is Tungsten Fabric. So I have those running, and then I also, if I do a kget pods, goodness, I cannot type today. This is the only pod I have running in just the default namespace. And if I do get services, I have a single echo headers service running in this environment. So here I'll jump over to this other environment. This is my other region. Again, KS get pods. I'll have the same type of thing. And I basically have, again, the same type of thing, the echo headers running and get service.
Hey, Will, while you're typing, is it possible to increase the font size of your terminal? It's a little, there we go. Great. Thank you, sir.
Yeah, here we go. And let me do it here as well. Okay, there we go. All right, so now what I'm going to do is I'm just going to, where am I? I'm on region 1. So I'm going to do a exec -it into here, bin sh, and I am now in the in this pod. So what I'm going to do is I'm going to grab the IP here and do a curl to this other pod. So this is essentially all it's doing is echoing back the headers for that curl. But essentially all this shows that I am able to connect from one region to the other region and have service to service communication between the two. Here I'll just log in here real quick and show the basic setup of how I did that. Oops. I'll log in here. So this is region 1. Are you going to load for me? All right, shift reload. Let's see if this, okay, here we are. All right, so BGP routers. Essentially what I have here is I have, this is the BGP router, there we go, in region 2. essentially it has a different AS number, and it is deployed on a different set of IPs. So I can't have, between these two clusters, I can't have overlapping IP space, otherwise BGP gets very confused. And so I have deployed Kubernetes to have different IP CIDRs for the pod and network, the pod and service network CIDRs in these two regions. And then I basically added a BGP router with a different AS number, so that the two different regions do peering on BGP and are able to share routes and such. So here you'll see this is the local one. Here I have an AS number of 64.512, and here I have it as 65.512. And so this is the other region. I don't really need to show it. It's essentially the exact same configuration. And it's essentially two different Kubernetes clusters running in different regions. Actually, I can show that as well. So here, workshops, CloudOps, and then I'll just log in. So in services, here I'll do in Quebec, I have region 1 here. I have just a master and a worker, and then this is my my networking. This is my underlay networking, and then I essentially have a site-to-site VPN set up to the other region, and the other region is here. It's this one, and these are the instances. Here is the networking, and then I have a site-to-site VPN set up for that one. So that is pretty much what we had scheduled for now. We're only 6 minutes over, and now opening for more questions. So let me just.
Awesome. Thanks so much, guys. I'm sure we could have gone even longer. I know you guys have so much prepared, so this is great. Thank you for your work. So let's get to the questions. This first one is from Brian, who asks, what kinds of workloads are you seeing deployed first using Kubernetes and telcos? For example, IMS, LTE core, PGW breakout, generalized, NFV adoption, etc.
Border session controllers for VoIP, for example, is one of them that I've seen initiatives doing that. Some of them deploying firewalls, virtual firewalls. And also, I've seen an example of management solutions. It's not exactly a VNF, but it's a monolithic application inside of a VM that's actually integrated with the VNFs, and they are trying to bring that into Kubernetes also.
Yeah, in addition, I've seen telcos virtualize their optical line termination, so VoLTs. That's something that I've seen as well. It kind of depends. One of the telcos that we're working with, they are basically rebuilding a lot of their services, that like end user services such as voicemail and SMS and that kind of stuff, to in-house developed products that are all running on Kubernetes. So in this case, it's not necessarily NFV workloads, but are basically telco services that are running in their environments. So yes, we've seen both for sure, both NFV type workloads and just modernizing the application stack on how the services are being delivered as well.
Cool. Awesome, thank you. Okay, here's the next one from Jesse. Are those telcos that are interested in transitioning their workloads to the public cloud, such as AWS, GCP, Azure, or are they staying in the private cloud, and why? What's the major concern or motivation either way?
All right, so this is a really interesting question, actually. This one. There's going to be some debate out there. I'll give you my take on it, and I am by no means going to be able to speak for the whole market, but I'll give you a little bit of some of the stuff that we've seen. So one of the things in adopting Kubernetes is it is actually a gateway for telcos to be able to adopt cloud services where it makes sense, because they will be able to have a standard practice for deployment and management of services and workloads. So it allows for them to have a common architecture or infrastructure on which they can build, and they can either run it internally or externally. And that has been one of the things that's been kind of like a key selling point for why they're using Kubernetes, because it allows for them to solve for what they need to internally, but also be able to leverage public cloud when it makes sense. And a lot of the telcos are still trying to figure out the legal and technical challenges, not necessarily as much technical, legal and security challenges around how they are able to leverage public cloud as well as on-prem, and which workloads can run in each. The other thing that I would say is that we're in Canada, and so the majority of the public clouds that are available today are operating in the US, and if they do have a presence in Canada, which many of them do now, they are still operated by a US organization. So if you have a telco, let's just say a Canadian telco for sake of argument or sake of conversation, it is a little bit challenging to adopt a US owned and operated infrastructure service provider to handle Canadian workloads, in a sense, because it is actually they have a certain amount of data privacy and such that they have to maintain, and if they put their data into a public cloud that is not owned by the same geopolitical whatever.
It's a matter of data sovereignty.
Yeah, there's a lot of data sovereignty that comes into play, and so yeah, that's one of the reasons why they haven't necessarily adopted cloud, is because they have to be able to account for where their workloads are running and who could potentially have access to them. So there's a lot more on this topic. One of the key things I think that I would like to be a takeaway on this is that the adoption of Kubernetes is giving telcos the choice. So some of the telcos that we are working with, they're using Kubernetes internally today in their data centers, but as they get a little bit more evolved around the business side of it, such that their corporate security or the other areas of the business that are very focused on the security and the data sovereignty and that kind of stuff, as they start to evolve and say, okay, yes, these types of workloads can be run in a public cloud, then all it is a matter of changing a deployment script and leveraging a public cloud, because the platform and how the applications are managed and delivered is able to take advantage of that infrastructure. I think that that's probably the key motivator, and is going to be the key enabler for telcos to be able to adopt cloud computing and still have a common application platform for how they're managing their applications. I don't know if that, yeah. Not sure if that answers the question perfectly, but yeah.
That was great. Yeah, and if you have a follow-up question to that, then just please ask it while we answer a couple other questions. Here's another one. Oh, and I do want to mention, one person said they lost audio, so please just let us know in the chat if you are able to hear us, just to make sure that we can still be heard. Okay, here is the next one. This is from Tehajwini. I hope I don't butcher your name, but you've asked a question earlier, so here's another one. Is Kubernetes multi-tenancy ready? And can telco network functions act as a separate tenant on public clouds?
So here's the thing about multi-tenancy in Kubernetes. I would say that, well, I would say it depends. If you have multiple tenants who are different organizations, and you require very hard separation of workloads, then Kubernetes doesn't have the best multi-tenancy for that specific scenario. In that case, usually what happens is you end up spinning a separate Kubernetes cluster per tenant. That's kind of been the industry standard to some extent, so that you just don't have to solve that problem officially. There are some nuances there, and depending on how hard of a line you need between tenants, like for example, if you want multi-tenancy, but really only from the perspective of separation of visibility and stuff like that, and it's less about the separation at the infrastructure level, then and that could very often be done with, say, multiple BUs in the same organization, business units in the same organization. Then in that context, then I would say yes, you can do it through namespaces and such. So I think it's a bit of a loaded question, and there's a lot of debate in the industry on that. I would say that it really depends on your situation.
Yeah, great, thank you. Okay, here's one more. So this is actually a follow-up to what we were talking about earlier around I/O usage, CPU usage. This person says, due to virtualization limitations, it gets difficult to get repeatable in performance. That's all. So there's no other context. So I don't know if you were able to answer that, or if you need this person to add a little bit more.
Can you repeat that, Matthew?
So basically saying that virtualization limits make it difficult to get repeatable performance.
Yeah.
So is this specific to the? This is just pods, no other. There's no virtualization in play other than Kubernetes in this context, I don't think, or other than containers.
Is it kind of created to using VMs inside of the same ecosystem?
We hadn't gotten there yet. This is specifically about pods.
I don't get exactly the point, to be honest.
Yeah, I'm not entirely sure. I think this was related to the conversation about the capacity and monitoring on the host versus what's actually in the what's actually deployed. In general, just back to capacity management, if it's really is related to that. In general, I recommend that regardless of how what you're scheduling and what you're allocating to your in terms of pods and such, that you are monitoring the underlying infrastructure and the and your host infrastructure very diligently. regardless of what's being scheduled, that is for capacity management and understanding the usage and whether or not you need to adapt based on the current usage of your infrastructure. You need to be monitoring the infrastructure directly and not be counting on Kubernetes, like what you've allocated at a pod level and so on. So I don't know if that answers the question, but definitely I would recommend doing monitoring at the host OS level.
Cool. Thank you. Yeah, and if you, Hajwini, if you didn't get your question answered, feel free to reach out to us on Slack.
Yeah, this is related to application performance running on Kubernetes and specific to pods. Okay. Yeah, I'm not gonna lie, I've definitely seen some pods not perform as well as expected under Kubernetes. That I have seen. There's also, it depends on the workload as well. I've definitely seen some applications that were not very well designed to be run in pods, and then the performance to really suffer because of it. A lot of people, when they develop applications, kind of are under the assumption that they can consume a absolute ridiculous amount of resources, because with Moore's law and such, we've kind of gotten lazy as developers, and I can say that because I am a former developer. We just kind of assume that that resources are available to us, and that there's always going to be a machine powerful enough to run this application. And for a little while, we got away with that because virtual machines were quite performant, and we were able to really leverage the most out of what the hardware could make available. I feel like there's a bit of a mentality shift that needs to happen again as people adopt containers, of being a little bit more resource sensitive and being a little bit more strategic about how you use the resources, and not assuming that you, just because you have a like beefy laptop, that is the best, that just because it runs on your laptop means that it can run anywhere. I feel like that's something that in the last decade there was a lot more focus on writing really lean applications a decade ago, on basically trying to leverage the resources that you have more strictly. And I've noticed recently that a lot more people are not really focused on the performance and consumption of resources, and as a result, as they move to containers and running stuff in Kubernetes, they've been a little bit shocked by the performance that they're getting. They're expecting more performance. So that's something I have seen. Everybody just assumes as well that just because you can get better density on the hardware by running containers, that you're going to get better performance in a pod. That's not really true. A pod is not going to give you better performance. It's just going to give you the ability to have better density on those nodes, because you have less overhead of running a lot of different OSs on the host, different kernels. So yeah, I don't know if that answers the question at all, but I hope it was helpful.
That was great. I learned. That's great. Well, that was the last question, guys. Anything you want to leave us with before I'll take back the screen and just close out with the last slide?
I think I'm good for this. If people are interested in our training, the Docker Kubernetes workshops at cloudops.com, check them out. We do a lot of workshops. We also do a lot of just community involvement. We're advocates in the open source community, and we are absolutely out and about. So if you want to look us up, if you want to to see what we're doing in the different open source communities, come check us out. And that's pretty much it.
The same on my side. Thank you very much.
Yeah, thank you all.
Awesome. Yeah, thank you guys so much. Let me just show my screen and just remind everybody that this session was recorded, so you will receive you will receive the recording and the slides after the session. And we have a survey at the very end. Just takes a couple minutes. It helps us, develop new topics, come up with new material, and see what you guys want demoed, what you all want to learn. So if you're able to take that, it's really helpful. And please give us a shout out on Twitter. Yeah, let people know what you thought. Help us grow the community, and please give a special warm thank you to the CloudOps guys. They did an amazing job with all of this information and really cool demos. So thanks again, guys, and have a great rest of your week, everybody. Talk to y'all soon.